Uh, Greetings of the day. Today, my topic of discussion is on searching techniques. So, myself, Dr. Purandhar N, Assistant Professor, Department of CSE Artificial Intelligence, Madanapalli Institute of Technology and Sciences, Madanapalli. The flow of presentation goes like this. The topics are introduction to searching, searching techniques, linear search with example, binary search, binary search with example, linear search versus binary search, and finally I'm going to conclude my topic with applications of searching techniques. So first I will start with the introduction to searching. So we know that searching is a process of finding a particular value or an element or any object in the collection of data. So the collection it may be an array, or it may be a list, or it may be a tree, or it may be a graph, or any structured representation of data. So from the large amount of any collection of these things, so we are going to find a particular item or a particular value or a particular element. So this process we are going to call it as searching. And here are some simple examples so that we can understand what is the searching techniques. We are going to search, as we know, we are going to search a particular contact number from the phone. And in the phone, we know that we have many hundreds of contact numbers are there. From that, we are going to find a particular contact number, whatever we require. And another example related to computer systems. So in the system, in the computer, we are going to maintain many number of files, and we are going to have many number of directories. So searching for a particular file in that particular directories, subdirectories, wherever it is. So that is also one of the example that we can consider for this. Not only for these two examples, we have many other real-time and technical related examples where we are going to search for a particular element or object from the collection of a large set of values or large set of items. Why we need to do searching process? So here there are many reasons are there. Here I am going to give some few examples where we need the searching process. The first one is efficient data retrieval. So whenever we have large volumes of database, so from that large volumes of database, if I want to search for a particular record or a particular object or particular value, so if you go with the normal way, it will take large amount of time. But if you follow a particular searching technique, the process will be done within short amount of time. And another example, problem solving and optimization. So there are different techniques are there which will be used to solve complex problems and to find out the best solution. So in that case, it is possible to use different searching techniques to solve that particular problem. So that is another example. And coming to the last example here, so the searching techniques will also helps for finding a particular a value or a record or an item from the large data sets so that we can save the time and the process can be done efficiently. And here is the different types of searching techniques available. So we have different types are there. Here broadly we can categorize into two categories. So internal searching techniques, external searching techniques. Coming to first of all internal searching techniques. So here the data set is smaller in data size, and it is possible to accommodate that particular data set in the main memory. So then we are going to follow a particular process to search a particular record or item from that particular smaller data set which is accommodated in the main memory itself. So if that is the case, then the searching techniques we are going to call it as internal searching techniques. And these are the examples which will come under internal searching techniques like linear search, binary search, and other searching techniques are there. Coming to the second type of searching techniques, it is called as external searching technique. Here the data set is larger in size and it cannot be accommodated in the main memory at a time, so that we are going to take the help of secondary storage or external storage so that we can optimize and minimize the disk accessing for referring or for getting a particular record from that particular larger data sets. So based on the type of data set, I may use internal searching technique, or I may use external searching technique for getting a particular record from the large databases. And for external searching technique, these are the examples like B plus tree searching technique, external hashing techniques, and many more are there. And first I will start with the discussion of linear searching technique. So the linear search process will goes like this. So given a particular list of values, and if you want to search for a particular element or value in that particular list of values, so it is going to examine each element in the list one by one until the target value which is found in that particular list or end of the list is reached. So given a list of elements and a target element which we want to search from that, so what it will do is sequentially it will start from the first element and it will go one by one, and it will go do that process until the target value is found in that particular list. If the target value is not found after reaching to the end of the list, it will stop the process. And the second point regarding this linear search is, so that can be applied either the elements which may be in sorted order or unsorted order. Whatever the property of the your list of elements, whether it may be in sorted order or unsorted order, we can apply the linear searching technique. And coming to another important point regarding this linear search, it does not require any additional data structure or any additional memory. Only the memory that is required for storing the particular list of values. With that memory itself, it is going to perform the linear search process. No additional data structure or no additional memory is required for doing this particular searching process, so that the linear, so this makes this linear search process space efficient searching technique. And coming to the last point regarding this linear search, uh, the time complexity can be like this. So in the best case, it is going to take order of 1, and in the average case and in the worst case, it is going to take order of n time complexity. And here is the algorithm or pseudocode to implement this linear searching technique. And this function or this algorithm will take two parameters. One is the list of values, and the list of values we are going to represent as array, and the target element which we want to search in that particular list of element is represented as a target here. And if you observe this process, we are going to use an iterative statement for loop, and we are going to start from the first element to the last element. So that index I'm going to represent with the I. It will take the values from 0 to that array length minus 1. So for every value of this particular I, so it is going to take an element from the array and it is compared with the target element. If it is matched, then it will return the index where that particular element or the target was found. So this process will be repeated up to it reaches to the end of the list. So even if you are reaching to the end of the list, if the target element was not found in the list, then it will stop the process and it is going to return -1 as a result, which indicates that the target element was not found in that particular list. And here is the example for understanding the linear search. So let us consider the list of values like 18, 35, 78, 23, 19 and 70. And in this list of values, I want to search for an element called 19. Now the process will go like this. Initially, we will consider the search element is 19 as a target element, and we are going to search one by one in the given list of elements. As I said in the previously that algorithm, we are going to take that position value or index value starting with I equal to 0, and k of 0 we are going to compare with the target element. K of 0 is 18 and the target element is 19, which is not equal, so that it will return false. So next I will go to the next element that is equal to in first equal to 1 index position. So that is a 35 and it is again not equal to 19, so that it will return false. Next we'll go with the next element, that is the 78 k of 2. So 78 is compared with the 19, again it is not equal, it will return false. Next it will go with the searching comparing with the 23. 23 is compared with the target element 19, again it is a false. So the search process is not completed yet. So now it will go with the next element, that is 19, so which is available in the position 4, and it is compared with the target element 19. So now the element in the list and the target element both are equal, so that it will return to, it indicates that the search process is completed successfully and the given target element is available in the given list. So to indicate that process, or to indicate that result, we are going to return the index value, that is I is equal to 4 as a result. Suppose if the given element or the target element was not found in the list, then it is going to return -1 as a result, which is indication that the element was not found or unsuccessful search. Next, coming to binary search. So this is another important, very useful and most popularly using technique, binary searching technique. So binary search extremely reduces the number of comparisons needed to find the target value by following the method called as a divide and conquer technique. So in the previous technique, that is in the linear search, if you consider, uh, suppose if the given list of values are 100, if the target element was found at the last position, so then we need to do 100 comparisons to search that particular element. So, but here in the binary search, it will reduces the number of comparisons by following the method called as a divide and conquer method. So instead of doing that 100 comparisons to find out the target element in the given list of elements, it can reduces the number of comparisons almost half of that particular size. And this divide and conquer method follows the approach, or the approach will goes like this. So what it will do is, it is going to divide the search interval in half, and it will compare the target value to the middle element and decides which half to you are going to continue with the searching process. So initially it is going to find out the pointer or the position called as a mid element position. So that mid element position will decide whether the required search element is available in the lower half of the elements or higher half of the elements. So this process drastically reduces the number of comparisons that are needed. So this process will be repeated until the target element was found. And one important limitation that I can say is, the binary search will be working only on the elements which are in sorted order. Whereas if you consider the linear search process, so it can be applied on either sorted elements or unsorted elements. But binary search, only the limitation is it is going to work on the sorted elements. And the time complexity goes like this. For best case, the binary search will also take order of 1. For average case and worst cases, it will take order of log n. So as we said previously, so it will reduces the time, half of the time to perform the comparison process. So that indication represents the time complexity as order of log n. And here is the example to understand, here is the algorithm related to the binary search. So the function will take two arguments here. One is the array and the target. So array will contain the list of values that we are in which we are going to search for the given element, and the target is the value that we are going to search in that particular list of elements. Here initially we are going to consider with the pointers like a low, which is going to be 0. So index 0 will be stored as a low value, and high value will be array length -1. So these two pointers will help us to iterate through the list of elements and to do the process of dividing the elements, everything. And here we are going to iterate through the list of elements by following this logic. Initially we are comparing with the low value with high, which is 0 less than the length of array -1. It will be true initially. And the first step is, we are going to calculate the position of the mid value, or the mid value index position, which will be low plus high divided by 2. So once we found that particular mid value index position, so now in the given array we are going to check that we are going to use that mid value index position, and that value we are going to compare with the target value. So in the first case, so if the mid index value is equal to your target value, then it indicates that the target element was found at the mid position, and it is going to return the mid value here itself. Suppose this condition is failed, then it is an indication that the element may be available in the lower half of the elements or higher half of the elements. So to do that process again in the next iteration, we are going to modify the pointers of low and high based on whether the search element or the target element is available in lower half of the elements or higher half of the elements. So the second condition comes here like this. We are going to compare. So if the condition is satisfied like this, that is, if array of mid values are less than target, then it is an indication that so the target element is available in the right half of the elements, list of elements. So what we are going to do is here we are going to modify the low pointer to mid plus 1. Suppose if this condition also failed, means it indicates that the target element is available in the left half of the elements. So to search in the left half of the elements, we are going to modify the high pointer as a mid minus 1. So once this process is completed, again the process will be repeated now with the now with the new low value and high value. So this process will be repeated until the target element was found in the given list of elements. Suppose if the given target element was not found in the list, so then finally it will come out from this particular iterative statement. So it will return -1. So as we said already, if you are returning -1, that is unsuccessful search, and it indicates that the target value is not available in this particular list. So here is the example to understand the binary search process. So consider the list of values like 12, 14, 25, 39, 41, 56, 78, 88 and 90, and the corresponding index positions are 0, 1, 2, 3, 4, 5, 6, 7, 8. And here I want to search the element 88 in this list of values. So we are going to consider this 88 as a target value, and as from the previous algorithm, we are going to consider this 0 index as a low value and the last index position 8 as a high value. So now after deciding the values for low, high, target, now we are going to do the process which we discussed in the algorithm. So initially we are going to calculate the mid value. So mid index position value. So mid value is equal to low plus high divided by 2. So which is equal to 4. So low is 0, high is 8. So 8 by 2 we are going to get 4. Now in the fourth position, index position, the value is 41. Now we are going to compare our target value 88 with 41. So the condition is, so it indicates that so 88 is available in the right half of the elements. So that what we have to do is we are going to modify that particular low pointer value to search the next iteration in the right half of the elements. So that the low pointer value will be now mid plus 1, that is equal to 4 plus 1, 5, and the high pointer will take the value as it is without any change. Now the next step will go with the new values for low and high. That is, low value is 5, high value is 8, and the target value which you want to search from the list is 88. So in the step 2, here if you observe here, so we are reducing half of the elements starting from 0 to 4. In those elements we are not going to search our required element. So as said in the previous algorithm, as we are in the binary search, it is following divide and conquer method. We are dividing the list of elements approximately into equal halves, and we are reducing the search process so that half of the comparisons will be reduced automatically. So now the list of values in which we are going to search is 56, 78, 88 and 90, and the corresponding index positions that we are going to consider here is 5, 6, 7, 8 only. So now low value is 5, high value is 8, and the target value is 88. So again the process we have to follow same process. We are going to calculate mid value position, so that is now 6, and in the sixth position the corresponding value is 78. Now again the target value is 88, which is greater than 78. So again, which indicates that the target element will be available in the right half of the elements. So that again I can reduce this list of elements into approximately equal half, and I can do the search process again. Now to reduce that, to do that process, we are going to modify the low pointer to mid plus 1, that is 7, and high pointer to 8. And here now the search process we are going to do only with the two values, that is 88 and 90. And as we said previously, the low pointer is 7, high pointer is 8 and the target that we want to search is 88. So we are going to calculate mid value. So that is 7 plus 8 divided by 2. So it will be rounded to integer value. Okay. In every step, we have to, whenever we are doing this process, if we are getting any fractional value, we need to round to nearest integer value. Okay, lowest we may go with either, for all the cases we may go with the lowest integer value or highest integer value. We need to follow the same process in every step. And the value that in that particular seventh index position is 88. So the target is 88 and the value that we found in the mid position is 88. So both are equal. So it indicates that the target element was found in the given list of elements which lead to the successful search. Now we have to return the index position value that is available from the mid value, that is 7. So this 7 indicates that in the 7th position the target value is available in the given list of elements. So again, the other case is if the target element was not found in the list of values, then it will lead to the unsuccessful search. Then we are going to return -1. That -1 indicates that the target element was not found in the given list of elements. And here is the comparison between the linear search and binary search process. And here I am going to consider some important, many parameters are there. Important parameters are like data requirement, algorithm type, time complexity, implementation simplicity, and use cases. So with respect to these features or parameters, we are going to search the linear search and binary search techniques. So coming to data requirement, so the data can be, as we said already, so the data can be either in sorted list or unsorted list, whatever the list of elements may be. So it can we can apply linear search here. Coming to binary search process, the sorted list of elements should be in the list of values should be in sorted order. Second parameter is algorithm type. So in the linear search, we will follow sequential approach. So that means we are going to search the target element by element, starting from first to the last element. So we can say that we will follow sequential comparison element by element to find out the target element in the given list of elements. Whereas coming to our binary search process, we will follow divide and conquer method. So as we said already, we are going to reduce the number of comparisons approximately to equal half of that particular elements. So it will reduces the time drastically. And coming to the time complexity, in both linear search and binary search, it will take order of 1 as the best case. But whereas in the linear search, for average case and worst case, it will take order of n. Whereas here, for average case and worst case, it will take only order of log n. So if you consider previous example, so we took 9 elements. Okay. So in that 9 elements, to do the comparison, suppose if our target element was found at the last position, here we need to do the 9 comparisons. But whereas here in the binary search, that many comparisons are not required. It will be order of log n. So if you consider, let it be 9 nearer to that 8 to power 3, so it will take only 3 comparisons. So as we said in the previous example, with the 3 steps we completed that process of finding the target element in the given list of elements. And coming to the implementation simplicity, the linear search will be very simple to implement and easy to understand, and it will be easy process. But it will be applicable only for the list of elements which are in smaller data sets. Whereas a binary search is, we may feel little bit difficult, but it can work efficiently and and it will be straightforward only. And coming to the use cases, so where we can use this linear search and binary search. So as we said already, so the linear search can be used for the smaller data sets, and data sets can be either sorted or unsorted manner. Whereas a binary search I can use for larger data sets, and only the limitation that is there is that the element should be in sorted order. And finally, this session will be concluding with the applications of searching techniques. We have many applications here. Here I represented few of the applications where we can use different searching techniques. So like starting with the databases, file systems, search engines, routing algorithms, spell checkers. So coming to first of all databases, whenever we have large volumes of databases, in that databases, if I want to search for a particular record, if I want to retrieve a particular record from that large data sets, I can use searching technique like binary search or hash based indexing searching techniques. Coming to the second application, the file system. So in any computer, the set of files are organized in directories and subdirectories. So if you want to locate a file or a particular directory in a system, so then we can apply this particular searching techniques like tree based searching techniques like B tree, like that. Coming to the third one, search engines. So whenever you are searching for a web page in the website in the net, so if you want to search for a web page, if it need to search for a particular required web page or relevant web page, it may follow different indexing and hashing related searching techniques. Coming to the another one, routing algorithms. So whenever we in a given network, so if you want to find out the shortest path between or optimal path between source and the destination, we may follow the searching techniques like breadth first search, depth first search techniques. Coming to the last application, spell checkers. So given a word, so we can search for a particular the word. So through the dictionary for getting the correct spelling or for any suggestions related to that particular word. Using any of the searching techniques like binary search or tree-based structures. So these are the applications where we can use our searching techniques. So thank you. Thank you.